All right, we're going to do another couple of examples, but first I want to write out the steps so that you have them all written down nicely so that we can use them for the next couple of problems. First, we need to list any restrictions, and these are things that would cause a denominator to equal 0. Then, we multiply both sides of the equation by the LCD. We solve the resulting equation, and we reject any extraneous solutions. Those are the solutions that look like they might work, but they're restricted because they would cause a denominator to be equal to 0. Let's look at just a couple more problems, and we will see an extraneous solution in one of them. So let's solve x plus 4 over 2x equals 2 over x plus 9. Okay, so first we have to list any restrictions. We know that denominators can't be equal to 0. And there's two denominators with variables in them, 2x and x. And both of these would be 0 if x was equal to 0. So the restriction is that x cannot be equal to 0. Now let's go through the process of solving this equation and see what happens. The next step is to multiply both sides by the LCD. This is what allows us to get rid of fractions. And here the LCD is 2x. So we're going to multiply both sides by 2x. On the left, the 2x cancels with the 2x in the denominator, and we're just left with x plus 4. Now on the right side, we're going to have to distribute this 2x. Here, 2x times 2 is 4x, and 4x divided by x is 4, plus 2x times 9 is 18x. So by multiplying by that LCD, we've gotten rid of the fractions and created a simpler equation to solve. Now we have variable terms on both sides, so we have to get rid of one of them. We can do that by subtracting x on both sides. That gives us 4 equals 4 plus 17x. Now, we want to get this x term alone, so we've got to get rid of the 4. We subtract 4 from both sides, giving us 0 equals 17x. And if we divide by 17, we end up with 0 equals x. Unfortunately, this is not allowed because we have a restriction. X is not allowed to be 0. This isn't a real solution because if we tried plugging it in, we would end up dividing by 0, which isn't allowed. So we throw it away because it's extraneous. This is extraneous. And because the only potential solution doesn't actually work, that leaves us with no solutions. And so we write no solution. If you're not left with any potential solutions after you throw away the extraneous ones, you've got no solution, and that's where you're stuck. All right, let's do one more. I'm going to do it down here. Let's solve x plus 6 over x equals -5. Again, we want to look at the restrictions here. There's one denominator that has a variable in it. That variable is x. And we know that that can't be 0 because then the denominator would be equal to 0. So the restriction here is that x cannot be equal to 0. Now I know that we've had the same restriction in all of the problems that we've done. However, if you look at the example problems in the videos linked below, you will find some that have a different restriction. So it's really important to go through those videos and see a wider variety of problems. But for now, the restriction is x is not equal to 0, and we can move on to multiplying both sides by the LCD. Now the only denominator here is x, so that means the LCD is going to be x, and we need to multiply both sides by x. When we do that on the left side, x times x gives us x squared. Then plus x times 6 gives us 6x, and if we divide that by x, we're left with 6. Then on the right, negative 5 times x is negative 5x. And this is a little different from the other equations because we have an x squared term. This ends up being a quadratic equation. And to solve this, we need to get all the terms on the same side. We need to factor and use the zero factor property to solve. So let's do that. I'm going to add 5x to both sides. This gives me x squared plus 5x plus 6 equals 0. Now we can factor that polynomial using unfoiling. We're looking for two numbers that have a product of 6 and a sum of 5. Those numbers end up being 2 and 3. So this becomes x plus 2 times x plus 3 equals 0. And now we can use the zero factor property and set each of those factors equal to 0. So x plus 2 equals 0, or x plus 3 equals 0. And then finally, to get x alone, we subtract 2 on both sides, giving us x equals negative 2 for the first one. We subtract 3 from both sides, giving us x equals negative 3. Neither of those are restricted, so both of those are solutions. So we end up with two solutions, x equals negative 2, or x equals negative 3. We sometimes will end up with quadratic equations when we're solving these rational equations, and in that case, it's possible to end up with two solutions. It's also possible that one of them works and the other one is extraneous. If one of them is extraneous, we throw it away, but we can keep the other one so long as it works. So lots of possibilities. There might be two solutions, there could be one solution, or we could have no solution.